So now we're going to do part 2 of how to work with this measurement data that we've been collecting. And so I have a couple of Excel files down here that are ready to be worked with. I'm going to go ahead and open up my PAST program. Let's expand it and let's go to the Excel files, and you'll see here I have a sample which is the one that we worked through and created in the previous video, the first video, the 10D sample working version 2. I also created a 10E sample working version 2 with different data. Notice these are different samples numbered here. You can see that they're not entirely sequential, 28, 29, 31, 32. A couple are skipped. Those were the specimens that weren't fully available, so we eliminated them. We created the same columns that we did in the previous set for square root, which is the geometric mean of the length times the width, and then the cube root, which is the geometric mean of the length times the width times the thickness. Went ahead and tested whether that data were indeed normal. The Shapiro-Wilk test highlighted here definitely shows, once again, the data are not normal. If we were able to say that they were normal, or at least indistinguishable from normal, those numbers would have to be less than 0.05. They are both greater than that. So this data is also not normal. I went ahead and did the summary statistics of both the square root and the cube root. I didn't hear they're not called 10D and 10 or 10E and 10E. Sorry, we'll correct that a little bit later. There's the means, but we want to work with the medians. So what we need to do first, let's go to the 10D and let's take the data from up here, this raw data again. I'm going to copy it. So I'm copying this column, everything but the mean. Let's copy it and let's put it into a PAST program. Remember, we paste that in there. And then we're going to go to the 10E and let's look at the square root data there. Let's copy it and let's put it in PAST this way. Let's edit it, put it in there. So now we have these here. I'm going to label these again, change this again. This is the, let's make it up front here, 10D square root, and this one would be the 10E square root. Click that off. Now the columns are named. We've already tested whether the data are normal or not. We know it's not, and so we have to use certain tests. But now what we want to look at here is we've measured these two things, taken the square root, the geometric mean, so we have that data there, from two different localities. These localities happen to be just a few kilometers apart, but these things could be thousands of miles or kilometers apart. They could be millions of years separated. They could be the measurements from one worker versus another worker. We want to compare. So what do? We go to univariate, and we're going to look at first two sample tests. So you kind of scroll down, hit that one, it highlights. Scroll over to the right, two sample tests. You click it. It immediately spits it out for you, all these different tests. Now, most of these are for data that is normal. We know that we don't have normal data, so there's two that we can use. The first is this thing called the Mann-Whitney, and then the second is the Kolmogorov-Smirnov. So let's click Mann-Whitney. The Mann-Whitney test, let's move this over here, is a test to see whether, so your null hypothesis is that the median of this column is equal to the median of this column. And you go down here where this Mann-Whitney U, and there's the p-value you want to look at. So the probability, the p-value, that these have equal medians, or that they're the same median, and look, it is 0.002. This is much less than 0.05. So we have falsified this hypothesis. So we can say that the medians are different. The median of this column is different than the median of this column. I'm going to go ahead and copy that, and then go back to I'll go back to sample 10E working. I go to one of my two working Excel files where I want to do some comparisons. You copied that data from PAST. So now let's paste it in here. Go ahead and put the borders all around this so it's there. We can then I'm going to highlight these two, and then usually I can type over here or write, if I print this out, that this therefore falsifies this test of equal medians. Let's go back to the PAST program. Now the columns are still highlighted. Let's go to the Kolmogorov-Smirnov test. And what this does, it tests for equal distributions, the shape of the size frequency histogram. And again, the p-value for the same distribution is much less than 0.05. Therefore, we have falsified this test. We are saying that the distributions are equal. We tested it. That is false. Let's go ahead and copy it. Go back to that same Excel file where we pasted those other statistical results. Go ahead and paste those in there. This Kolmogorov-Smirnov test. I'm going to once again draw the all borders on it, and I'm also going to, let's just make sure we highlight that particular row right there. So the p that these have the same distribution is also less, so this is also falsified. So we've gotten two tests here that have basically said that this data that we're looking at is not equal. Not equal medians, not equal distributions. There's one more test that you can use, and here you'd go to univariate statistics, scroll down to ANOVA, click it, go over to the several sample tests. Again, most of these use normal data, so we can't do anything with them, but if you go to Kruskal-Wallis, you click it here, and this does the test. It does the same sort of p-value game that we were talking about before. This once again is much less than 0.05, and here they actually make a significant statement for you that there is indeed a significant difference between the sample medians. Let's go ahead and copy that again. Go back to that same Excel spreadsheet where you're putting all that other data. Go a couple rows down, go ahead and paste it in, and you can then put the all border there, and I'm going to highlight that row, and I'm going to highlight this row too, just to make sure we see it here. So now we've taken that data that we showed you how to generate in the first little video, and now we've done some actual statistical tests and made some statements about whether we have falsified or not falsified our null hypotheses. Our null hypothesis is that these two columns are equal, therefore that means that the populations are equal, they're the same sizes, etc. And we have falsified that. in 3 different tests. This is very rigorous data that we can now use in a publication, a report of any kind. You've generated it. It is saved in this Excel file for you. We've highlighted the relevant things. Anybody can find what you've done and see your work, as it were. Go ahead and save it. And you're done for now.